All right, this is the last talk of the conference. Wow. And I didn't know that whoops, wow. There we go. Okay, so now this emoji is really appropriate. That was really weird. So what this emoji was really here for was just the fact that I'm last, right? So I had actually prepared all the slides because I had scheduled this talk as a brown bag for a code school a couple weeks ago, and then did a practice talk at work too. And then that afternoon, right after the practice talk, they posted the schedule, and I found out that I'm last. And I was like, oh man, I don't think I can do the talk I just prepared because it's really code heavy, and I just can't do that to you all. Like, I know what it's like. I've been to a lot of conferences. So we're not going to do quite the originally scheduled programming. It's all in here. There's a lot of code, a lot of annotated code examples and interactive examples. I tweeted this slide deck as well. And all the resources that you need to do the examples are like live as well. There's a server up there with a MongoLab instance. Please don't destroy it. So you can check them out later and like look at the code in detail. What we're really going to do is just kind of breeze through the code. And then there's a demo at the end that I put together that's all about this guy. This is Bob Ross, for those of you who don't know. He had a PBS painting tutorial television show in the 80s and 90s. And he has a very soothing voice and some really memorable just phrases that he likes to use, like happy trees. So he's become kind of hip again. They do an annual stream that's pretty fun on Twitch. So you can check that out. You can always access it at all times at twitch.tv/BobRoss. And it's also available on Amazon Prime, like all the seasons, at least the last time I checked, which was not that long ago. So, again, slide deck is online, and I also tweeted it. I'm iPancreas on Twitter, and J.E. Beck most other places on the internet, like GitHub. And I work at a place called Stitch Fix, as Dave mentioned, in the algorithms group, which is what we call our data science group. If you don't know what Stitch Fix is, it's an online personal styling service. So you sign up and fill out a style profile, including your size, color preferences, fit preferences, style preferences of various sorts. We match you with a stylist who picks out 5 things for you, clothing and maybe some accessories. And this is for women's and men's clothing lines, by the way. And kids as well. Try on everything at home after we ship you the box, and then you just pay for what you want to keep. You send everything back, free shipping. And we're very data science focused. So we use data science in warehouse assignment, recommendation systems that are matching styles to clients, client stylist matching, so putting those humans together, human computation or HCI, logistics optimization, demand modeling, inventory management, new style development, which is one of my favorites. So that's where we build these models about what features of clothing perform best together. So things like neckline, color, hemline, sleeve type, things like that. There are a lot more of these features in women's clothing than in men's, but there's science to be done there for men's clothing as well. And then we put together like the best performing or the predicted best performing attributes and actually produce those styles and send them to our clients. If you want to know a little bit more about this, there's a really fun animated tour of all the data science that we do. It was actually a finalist for the Information is Beautiful Awards. So check that out. Again, there's later if you want, there's a link here. And then for some milestones here, we're going to have some like 4 milestone GIF breaks, famous Bob Ross moments here, just to give you some like landmarks on the way to the end of this last talk. So a better title, but less catchy for this talk would have been Better Living Through Non-Presentational Components. Because that's really what we're going to talk about. We're going to talk about components for data fetching, persistence, and computation. That's the really fun one at the end. I'm going to set a little bit more context to start about our team at Stitch Fix, and then we'll talk about fetch components, save and delete components, and then we'll get to those fun compute components. So the context. We have a pretty large team. It's about 90 data scientists and 25 of us on data platform engineering. Only 3 of us are front end on data platform. The data scientists are organized in verticals with the business. But the data platform is organized horizontally, serving all the data scientists, and then we sort of specialize, whereas the data scientists are what we call full stack data scientists. So they are encouraged to own the full stack of their work. That means writing ETL, extract, transform, load, to produce the tables that they need in our data warehouse to do their work. Putting up services if they need, if their work requires like live services. We have tools to help them. One thing I was talking to someone else about is we have a tool that basically takes a Python function and you can deploy it as an entire like REST service with a health check endpoint, monitoring, and endpoints. And so they use that a lot to put up services. So these are very technical people, but not with front-end development. And they also are expected to, if they need to put together a dashboard or a simple web app or sometimes a complex web app, they are also expected to pretty much own that code. So these are some of the things that they are experts in. Probably the two biggest ones are Python and R, which is a statistical programming language. And then Spark gets a lot of use on our team. This is only a small sampling. Our stack is really big and complicated. There's like a huge diagram, and I'm not going to go over it because it's not really relevant for this talk. But I can tell you about the tiny slice of our stack, which is a service that we call Fogtown, which is the way that web apps interact with our data warehouse. So this service takes in GET requests. It basically executes limited SQL against tables in the data warehouse via a query object that is part of the request headers. So this app just looks like this. It's a Flask app, and it takes the requests from the client and sends them to Hive and Presto are sort of a pair here, where Hive is our data warehouse meta store for schemas, and Presto is our ad hoc query engine. And then Redis is there as well as a caching layer because a lot of our tables only update daily, so we can get a lot out of caching and reduced load on that Presto engine. So that's the rest of the context. So now let's dive into these fetch components. But first, another little break here, some happy trees. All right, so fetch components. So the inspiration here, I can't take credit for this idea of using components to do sort of non-presentational data-related things, like asynchronous data-related things. I really got the idea from this talk by Ryan Florence this is the title of the talk, the little component. This is from React Rally 2016. I really recommend watching it. The content is amazing. And Ryan is like a master live coder, so it's really fun to watch. And basically the thesis of this talk is we didn't give components a fair shake yet. Ryan gave this talk, I think, mostly at the height of the Redux craze, and at least in the React community in 2016. I think he's probably partly responsible for the backlash that Ben just referred to with like this talk and talking about it elsewhere. And when I first got to Stitch Fix and I saw a lot of the simple apps the data scientists had put together, the advice at the time had been to use Redux. So these data scientists who are not web developers were like using Redux in these very tiny applications where all the data that was getting fetched was only being used in one place, like for one chart, right? Which that's not the use case for Redux, which is really good for making sure your state is in sync when you're displaying the same state in multiple places on the same page. So I really, I'd seen this talk and I thought, let's try a different model and like make some components for the data scientists to use instead. So this is the example that Ryan basically showed in his talk. So I was going to start with that. Just going to highlight very tiny pieces of it, which is basically that you're doing the work of the request in the mount lifecycle hook. So component did mount here. And then using the render props pattern, which was discussed at length yesterday, so I don't have to talk about that as the render. So our initial fetch at Stitch Fix looks a bit different. This is zoomed out a lot. There we go. Looks just a tiny bit different. We don't use the render props pattern, or we do now actually as an option, but our default is to clone a child that the consuming application or consumer of this component has put inside, and then injecting the state of the fetch component as additional props. And then we also do some default renders of loading and error states, because we really want the data scientists to be producing good apps, right? Apps that have good UX, but that they don't have to spend the time writing that boilerplate. So the reason we didn't go with the render props pattern at first is because the most we can really expect of a data scientist that's totally new to React is that they do the intro tutorial on the React official docs, and that does not include render props. Render props are way in these advanced guides, which I think makes sense. They are an advanced pattern. But we just thought that we wanted to use a true, just completely component model. No weird functions as children. So I'm going to kind of skip over these code examples. They're just about making it more generic by passing in things like the method and the props. This one I think is a post, if I remember right. Yep. And like, it's actually really nice giving a talk when like the internet is so bad that you can actually see those loading states. Like when I run this at home, like you can't see the loading state, right? That's the one nice thing about slow internet. So then finally, we did make fetch more generic by basically doing a conditional render prop. So we type check on the children, and if it's a function, then we just use that as an escape hatch to let you use the render props pattern. This was mainly the people on, as I said, I'm one of 3 on a front-end team and data platform, and we use these components a lot too, because we do have apps that we own. For example, we own a pretty complicated UI on top of that Frogtown layer for interacting with the data warehouse. The UI lets data scientists browse tables and databases and see all sorts of information about the schemas and things like that. So we wanted to use this pattern because, you know, it's a nice pattern. It lets you do some more things like nest some of these fetches and just control a little bit more. So we basically just added that as an escape hatch. So that's actually, this is an interactive example of that escape hatch. So that's the fetch components. So now another gift break. In this one, I really like the caption, so I'm going to read it for you. Bob Ross says here, when you're painting, you have that artist's license that says you can do anything. And that I chose specifically for this next section, which is on save and delete components. Because when I first had this idea, like I'd done the fetch and I was actually working with a data scientist who was working on the app where they put together these hybrid designs using the data science to combine the different aspects of clothing that perform the best. And so he needed saving functionality in that. And I thought, well, I wonder, it seems kind of crazy, but maybe we can do that as a component too. We do have this service that's for generic non-data warehouse storage that everyone kind of shares across our algorithms team called Red Velvet. So that accepts all kinds of requests. But here, you know, with the GET request, there's obvious lifecycle methods that hooks into. Like we already saw componented mount. If you're ever changing an aspect of your request and you want to rerun it, you would look for those changes in componented update and fire it off again. But for post and delete, there's like not an obvious lifecycle method, right? And that's because these are dependent on user action. So instead of a lifecycle method, we want an instance method, basically. And we need a button. So these are now mostly non-presentational components. So we do render a button, and instead of doing fetching in a lifecycle method, we're doing it in this handle click instance method. So this is an example. Again, I'm kind of trying to get you all out of here, so we're going to skip through these code examples. The big point of this section is that we want these buttons again to provide good UX. So we want to do things like passing through the disabled prop. So here now this is disabled until we have some input. And we want to reflect like in-flight requests. So we can see the text change. That's like an easy way to do it. And then we also want to have a way to keep the data fresh, right? And hopefully without adding Redux if we're still in a very small app. So the thing that we figured out to do this is actually better. You can see it better on this slide. So as part of the success handler of the request that's in the click handler, right? We can pass in a callback function in the props for your button, your save component, and then fire that off as part of that success. And so that callback most commonly will be a method that does the fetch again, that refetches the data once it's been saved so that you get it, you get a fresh copy. So here we can see that in action by saving something else. and now it updates in almost real time. So we do have some apps where we use Redux a little bit. If they get complicated and we need to show the same data in multiple places in the page and there's not a strict like parent-child relationship, then we will use Redux just for data fetching. We'll keep it very small, like it only fetches the data that we really need to be in that Redux. And then we use these components for the persistence part, and we put an action creator in that callback slot. So it works out pretty nicely, actually. So now, what about the delete components? Well, this one I'll leave as an exercise for you. They're basically exactly the same as the save components, maybe just different button text and different method. So before we get to the fun demo, just a little conclusions of what we've seen by having these components in use for about like 6 months to a year, somewhere in there. I'd say that components as sort of a deliverable, as an internal tool, make a good tool set when you are in an environment like ours, where you're building a lot of apps, so a lot of small or mostly smallish apps, and that those are built on shared resources. So we have, one generic fetch component, one generic persist component, but we also have, I think we have like half a dozen total fetch components. And so some of them have specific props for the resource that they are intended to be used with. So then even the host name is hard-coded in the component, right? So no one has to remember that. And for the Fogtown fetch, for example, the database and the table and the query are all props that you pass in, and the prop API is just very intuitive for that particular resource. Components are also a good unit of abstraction, which seems like a real truism to this crowd. But what I really mean here is a good unit of abstraction for people who are not front-end developer experts. Components are pretty approachable. They're encapsulated. They tend to be almost single file, if not, maybe we have some like core, kind of internal components that the other components rely on. So they might not be quite single file, but they're close to it. And so even the data scientists can look at the source code if something isn't documented and it's all like in one place. And they're very easy to document because there are a whole wealth of tools that are basically aimed at documenting components, not usually at documenting non-presentational components, because these are like style guide tools, but those tools are there. So we actually use Storybook, but there's others out there. So there we are. Now we are at this final stage of the big demo with the compute components. So your first question here is probably compute in the browser. I thought data scientists used like big GPU-enabled clusters on Google Cloud and AWS, and sure, they definitely do. But there is some data science that you can do in the browser, which you can't see that. So this is a project called TSNE for TensorFlow.js. TensorFlow.js is a JavaScript version of TensorFlow that has a whole bunch of different machine learning things in it. TSNE is T-distributed stochastic neighbor embedding, which probably doesn't help you at all. Another way to say that is that it's the category of thing that TSNE is a technique for dimensionality reduction, which also may not help you. But in a much simpler way to say that, if you think about data that has more than 2 or 3 attributes, so more than what you could just do on an X and a Y or an X and a Y and a Z, if it's got like 6 or 10 or 200 attributes, then TSNE is a method, an algorithm for grouping the data in 2 or 3 dimensions, so that you can see the ones that are most similar to each other in like that space together. So we're almost there to the Bob Ross part, but actually we're not quite there, because first we're going to do a little thing with wine. This is just because it's a little easier to show you what I mean by dimensionality reduction. So this is an example. This data set is just because it took me actually a few hours to find a good demo data set. This is from a big repo of like free machine learning data sets. And a lot of them are either too tiny or way too big to do in like a browser demo. This one is about the right size. It's 178 wines with 13 dimensions. So that's the attributes listed here. There's 13 of them: alcohol, malic acid, ash, etc. So that's what we mean by dimension. And then the first one is this class. This is actually, we're going to hide this from the TSNE because this is what we're trying to get it to classify to see if it works. There's actually 3 classes in this data set. They were like 3 different cultivars of wines from some region in Italy. So what we want to see is that the TSNE actually classes them, clusters the 3 different classes appropriately, will color the docs according to the 3 classes. So cross your fingers for me here, since I already had that weird bug. All right. So this one, it takes a second. There we go. Oh, so I was going to mention while it's running. So this is using TensorFlow.js. It's actually a fork of TensorFlow because this is using something called off-screen canvas, which just landed in Chrome 69 like 2 weeks ago or last week or something like that. It's amazing. And it allows you to do WebGL in a web worker. So I forked the TensorFlow.js codebase in order to get the off-screen canvas available as a potential target for their WebGL backend, as they call it. And there is a pull request open, so hopefully that actually is going to come into the main code base. I would open a PR myself, except that that code base is moving so fast that my fork is already like super far behind. I actually did the fork like 3 months ago when off-screen canvas was only available in Firefox Developer Edition. So we see that it worked, right? The classes got clustered appropriately. So I'm going to close that tab, actually. And then just a little bit more about why doing this as a component. So why you would do Teasney in the browser is basically if you have a data set that updates frequently that you want to display in this way or explore in this way, then you would want to do it in the browser if you can. And making this declarative. This procedure is actually, all that moving we saw at the first is because I turned on the prop on this component called iterate to show you all the iterations. And the default there is set to 1,000 iterations, which is actually pretty low for doing a Teasney. A lot of the server-side solutions, people default to a much higher value. And then the other big reason why you would want to do this in a component is to kind of componentize it and cache that computed result. So I have a prop on this. Actually, I'll show you with the Bob Ross example. So there's a prop here that you can add, and we will see it, where you can turn on caching. And then it won't recompute. So that's really useful when you're developing how you want to display this, because you don't want to keep recomputing. These examples I'm using compute very quickly compared to real world data sets that have like tens or hundreds of thousands of data points and like maybe hundreds of dimensions. So it can be very painful to develop in the real world without caching. And then you also get better UX in your app if you have caching, because if the user navigates away and then comes back, you want to just like show them the result again. So we're all done. It's time for Bob Ross. Now, where I got this data, the lovely people at 538, a couple of years ago, I think, put together this, hand-coded this data set, every single painting from every single episode of The Joy of Painting, coded with like what's in the painting. So this isn't by color or anything like that. It's by contents. And also things like what kind of frame, because sometimes he does like these oval frames. Whether his son was in the episode, I think, is one of the columns as well, one of the dimensions. So here we are at last. All right, and so I put this hedgehog GIF in there to prove to you that it's happening in a web worker while it's loading. So there we are, Teasney on Bob Ross. And so obviously this is small, so we can zoom in and explore a little bit here. So this is non-deterministic, so every time I do it, I get something slightly different. You can see a bunch of the oval ones like turned up right in this area. And this is definitely a mountain section. We've got a bunch of dark things. It's really interesting sometimes when they do kind of cluster by color, even though that's not part of the data. The 2 people, there's like only two paintings, and this is 20 episodes. I was only able to download so far 20 episodes of images. It's 260 images. There's 13 episodes per season. There's only 2 so far that have people in them, and they're pretty close to each other. All the waves are here. Usually there's like a cabin section. Can't find the cabin section. Oh, here's one cabin. But yeah, lots of mountains. A lot of his paintings have mountains. Here's some river scenes. Yeah. So this is just a fun thing. I'll zoom back out. There we go. Let's run it one more time, just for fun. I'm not showing you the iterations on this one. The browser kind of falls down on the images, moving them around, because I'm not doing anything fancy in terms of the browser rendering for performance. That result wasn't very good. TSNE is non-deterministic, so you get different results. Interesting. And then just to show you a little bit on how that API works, you can stick that cache prop in, and it actually get the exact same thing back. With this one, it decided was totally a loner. So that's it. Now you've seen this slide like 5 times. Thank you.